And if this goes off, just push the power button.
Okay, we're live now, Jim. If you're not
Thanks.
anything, then...
Well, I mean, we're going to start soon, so might as well.
Hans, can you speak?
I can speak, yes. No, can you hear me well right now? Do you get any sound, any audio? No.
I've got new little green lights that say yes, but...
Hello, 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 hello. It's funny. I could hear me speak.
I can hear you. It's just really delayed.
Right.
That's fine. The delay is fine because we're not dealing with it in the room. But like right now, when I take my hands off things, Jen, how's the audio level?
Hello, hello, hello. Can you hear me with a delay?
Okay.
As long as I don't hear the delay, I'm fine. I'm happy.
Louder, softer, just good. Low. Try again. Can we touch more time?
Hello, hello. Can you hear me? Can you hear me?
Yeah.
Good. Is that good? Good level.
Yeah.
Okay.
Okay. So, ready to roll? Cool.
So just a second before you start, just a couple of logistic things.
Yeah, of course.
Welcome everyone. My name is Jeff Brown. I work for OCI. I'm the Gradle's practice lead, and OCI and RGA conspire to co-sponsor this meetup every month, and this is just a really fantastic facility to host this sort of thing. So we're really grateful to RGA for supporting that. A couple of logistic things. If you have to go or would like to go to the restroom during the presentation, if you go out this way, just turn out this door and turn left. There's a security guy out here who will see you where you need to go. If you don't work for RGA, don't have a badge, you need to not be roaming around the building without an escort. So there's a security guy right out here. You'll see him when you walk out here and turn left, and he'll take it from there. And at the end of the night, when you leave, if you leave through this exit door right here, and then walk along that hallway, you'll just be going that way.
Actually, stairs just right outside the door.
Stairs right outside the door.
Right.
We're farther down than I thought we were. And that way you can get out without an escort. So again, at the end of the night, don't wander around this way without someone with an RGA badge. Just go out that door and you'll see where you're going. And I think that's all. Other than I'll just quickly introduce Hans Dockter. Hans is the main man behind Gradle. He founded the Gradle software and the Gradle company, and he's going to talk about developer productivity with Gradle tonight. Thank you very much for coming, Hans, and I'll turn it over to you.
Thanks. Thanks for the introduction. Yeah, welcome to this talk about accelerating developer productivity. So, what is this? So that is when I look at, we have a lot of experience, right? We did consulting for the last 5 to 6 years across the country, right? From the Silicon Valley heavyweights to the banks on the East Coast to many engineering companies, right? And there might be a handful of companies at scale where we think they have an efficient software delivery process. The rest is somehow in this state when it comes to developer productivity, and a big problem of developer productivity is the build, right? That's at least the companies we are working with. And the interesting part of that picture is some people got used to the pain. So they say, hey, actually we can still see through one eye, right? We can still breathe through one nostril. Our situation is not that bad. Well, looking at from the outside, well, I'm not sure. I don't want to be in that situation, but people get used to pain. But what we're seeing, and where the level of pain reaches a point where it's not acceptable, the octopus gets more arms, right? So what you're seeing is a dramatic increase of complexity for building and delivering software in a microservices world, where you have many more repositories, and so that is where it's one of the big challenges. And then obviously more and more platforms organizations need to support. It's Java, it's JavaScript, it's Android, it's iOS. That's another big challenge. And number 3 is simply the code bases are growing and growing and growing. So the scale you have to build is increasing all the time. And so you have to do something about that, right? And on the flip side, it's a gigantic opportunity. So companies with high developer productivity will win, right? And so it's an opportunity, but it's also a risk, right? So and let's look at an example. Let's look at LinkedIn. LinkedIn in 2011, with 1,000 engineers, deployed a new version of their complete software every 30 days. So is that terrible? No, it's not. I would say most organizations on that scale would be happy to be in that situation. They're still trying to, maybe they achieve quarterly, right? And yeah, but there's another interesting kind of factory perspective you can have on that. So when you release every 30 days, right, how long will a finished feature be in the shelf, not creating any value for your organization?
30 days. As much as 30 days.
Yeah, but average 15 days. So the average inventory term is 15 days, right? So, and I kind of like to have a manufacturing perspective on software. It's sometimes helpful, right? So, and then what LinkedIn did, they were very, very aggressive in saying, hey, we want to be absolutely outstanding when it comes to delivering features very, very fast. And they got it down within 2 years to 2 releases per day, right? And that means they have decreased the inventory term to 0.5 days. I mean, if you look at it, if a factory can increase the inventory term by a factor of 60, I mean, this is like, you would blow everyone away. Now, let's assume this company will start getting into your vertical, right? And you release every 2 months, every 3 months. Goodbye. Seriously, you have no chance. Considering, they get inspired by your ideas, you get inspired by their ideas, you cannot win that battle. So every company that is now competing with LinkedIn is in trouble, right? And we'll see the same in the car industry. We will see something like that in the financial industry. Of course, regulation can protect some industries more than others, but nonetheless, the companies that are not able to go in this direction, right, will vanish. We've seen that now a couple of times happening, right? When certain verticals got attacked by new players, and at the same time, it's an opportunity. I would say one reason why companies kind of lived with terrible developer productivity, right, for a long time is that the companies in their vertical the competitors were not doing better. And now we have a situation, increased pain and more threats, right? So at the same time, we are still at a point where if you invest, right, and there's no free lunch, LinkedIn invested heavily. This was not just falling from the sky. They had full backing from the upper management, right, to get there. And there's an interesting article in Wired that translates that capability to the economic success LinkedIn had. It's now acquired by Microsoft, right? And Gradle played a big part in that success, right? So it's the build tool that LinkedIn is using for building everything, right? For now 2,000 engineers, right? So, okay, so how does Gradle relate to that, right? So why should you be interested in the Gradle build tool, or what is the key value proposition? One is build anything, right? So LinkedIn is using Gradle to build 42 different languages, right? And I didn't even know that so many languages were out there, right? So Gradle is not just a Java build system. It's Java, C++, Android, Python, all the JVM languages. There are plugins for Gozu, for building R packages, right? So having a unified build system, and it doesn't necessarily mean that Gradle does everything for a certain platform. So for example, for JavaScript, they integrate with other JavaScript tooling that is out there, but Gradle is still the orchestrator and the wrapper around that. So build anything. The other thing is, and that's a different point than build anything, is automate everything. So what we see, and what is a big part of developer productivity, is that the degree of automation is often not high enough. Things that should be automated are still not automated, and people somehow manage it manually or not do it at all or not frequently enough, right, because of that. So Gradle is not just a build tool in a classical sense, it's a generic automation tool, right? Be it connecting to AWS, generating documentation, whatever you want to automate, Gradle is your friend for that. And it provides you a lot of cool services if you automate with Gradle. Parallelization, incrementalness, a new build cache where you can share build output across developers. I will talk about that in a second. And finally, deliver fast, right? So speed is important, and that's an area where I think we need to, as an industry, become more professional. So it's kind of funny when I talk with build teams, or as now named into developer productivity teams, right? When I say, what pain do you have? They define pain by, is someone yelling at them, right? So they're not looking at data and say, oh, people are not complaining, no pain, basically. But that shows that they're kind of in that spot, basically in survival mode, right? As long as people are not trying to kill them, they think in that area we're in good shape, right? In the other area, people are trying to kill us if we don't improve the situation. So, even if people are not complaining, right? As an industry, we need to get more aggressive, right? If something takes 8 minutes and people think it's fine, well, if you can do it in 1 minute, and this is a step that you execute 500 times a day, you're crazy not to do that, and you leave hundreds of thousands, depending on your team size, or millions of dollars on the table if you don't do it. So deliver fast and become ambitious about that is a key thing why you should use the Gradle build tool. And then we have now a complementary offering, and I will talk more about that later. It's called Gradle Enterprise, which is a service, can connect with all your local Gradle builds and CI builds, and this collects all the data from all the Gradle builds, so you can measure and optimize all your builds. You can accelerate the debugging time, so when there is a problem, how long does it take to fix it, because we have interesting data that we can offer to you to make that faster. And we provide some enterprise-grade services like distributed cachback and other things to make your builds scale to a very high degree. Okay, so let's talk now about some of the features that I think are relevant for developer productivity with Gradle. And so one is up-to-date builds. So and caching build output. So from what I understand, most of you are Gradle users, right? I think there was only one person who was not using Gradle. So you all know Gradle tasks, right? That is the unit of execution. You run a Gradle task. And the Gradle task has dependency and calls other tasks. You know that game. So, and a Gradle task has inputs. And then it's the actual task implementation, a compile task, a test task, a documentation task, whatever that is, right? And the task has output, compiled classes, a PDF file, a jar file, whatever, right? So in the case of compile, right, the inputs would be a configuration setting. Source compatibility is 1.8. It would be the actual sources, obviously. What else would be the input to the compile task? For the input? Yeah, the output directory, yes. Dependencies. So the class path, right? So, and strictly speaking, also the Java version that is being used, right? Not just the source compatibility, right? And anyhow, but you get the idea. And the output is simple. In this case, it's the classes, right? So, and who of you has ever written a custom Gradle task? So you know, on the next slide, so when you write a Gradle task, and of course all the tasks Gradle is shipping, use that mechanism. Tasks have input properties and files and output directories, and you can annotate them. So you can tell Gradle, hey, this is an input, this is an input file, it could be an input directory, this is an output file. You get the idea. And oops. So, and with that information, we can do interesting stuff, right? So one thing we can do is whenever you run a Gradle task, right? Gradle hashes the inputs and outputs of that task and puts it in a cache directory, just the hashes. And when you run the Gradle task again, Gradle looks, are there some, when I run it previously, what are the hashes? And it compares the hashes of the last run with the hashes of the current run. And if they have this, if they represent the same input and output, then the task is up to date and Gradle does not run it. If not, it executes the task. So this is a binary mechanism, up to date or not. There's another interesting capability in Gradle, and that is something many people are not aware of. When you are the task author of this task, and Gradle tells you, hey, something has changed, you need to execute. Gradle also provides you an API where you can ask Gradle, hey, Gradle, what files have changed, right? What files have been removed? What files have been modified? So depending on the task, you can then decide, hey, actually, I only need to rebuild some of the output. Let's say you have a source code generation task that generates out of one XML file a Java class, right? And Gradle would tell you, hey, only those 2 XML files have changed, and you only need to regenerate those 2 XML files. But that is not up to date. That's what we call the incremental API, right? The up to date stuff is a generic thing. It's binary, execute or not execute. And when a task is executed, it can either behave incrementally or not, right? That's up to the task author, and it depends on the domain. For example, the Java doc task, it's almost impossible to do it incrementally because of all the navigation and all the stuff that is in the HTML pages. So we always have to do, for Java doc, we have to say, okay, we have to remove all the output and have to rebuild everything. For other tasks, that's very different. Okay, so that is a pretty cool mechanism, right? And you all, I guess, when you're using Gradle, know that kind of up-to-date output on the command line, right? So, but we want to do more in terms of avoiding tasks being executed. So the current mechanism works the following, right? When the content is the same as the last time when we ran this build on this machine without a clean, then a task is up to date. When you do a clean build, you deleted your output from the previous build. There's no up-to-dateness. We need to rebuild it, right? When a developer on another machine runs the build, well, it doesn't help this developer. And also interesting, when you switch between feature branches, who of you is using Git? Right? So most of you. So when you are in feature branch A, and then you switch to branch B, and you do a build, it overwrites the output from building branch A. So when you get back to branch A, you have to rebuild again, right? So this is a cool feature, right? But it has its limitation, so we add another layer of caching on top of Gradle, the new build cache. And so what we want to do is basically, not just from last time, from any time when we run this build on this machine, right? We want to preserve the output. So with the new build cache, whenever you run a Gradle build, we store the output over time. The output doesn't live, for the new cache, doesn't live in your build directory anymore. It's stored in a separate place, right? And for example, when we run the compile cache, we calculate the key based on the inputs, and then the key contains the hash of the sources, the class path, etc. And then we publish the compiled classes into that build cache with the key. And then let's say you switch to feature branch B, you build, you go back to A, we say, hey, we have this key. You don't need to recompile, we just get it from the cache. You get the idea, right? And the more computational intensive your task is, the more you will benefit from caching. So for example, we would not cache usually copy tasks. By default, we don't cache them. It doesn't make sense, right? Just copying from A to B, there's nothing to cache, right? We don't cache a delete task, but a compile task we cache. And let's say when you start using annotation processors and compile gets much longer, right? Then things become even more interesting. Okay, so that is a detail. So when you check out Gradle, when you check out a Gradle build in 2 different directories on your machine, without the build cache, when you build one, you still have to build the other. Gradle is not exchanging information, right? With the new build cache, that will be different. With the new build cache, it's not just your machine anymore. With the new build cache, you can share build output between developers, right? And that is, this is the SSD for your builds, seriously, right? And finally, it works also for clean builds, right? This output is stored not in a build directory, right? So it is stored in a cache. So all your CI builds will get dramatically faster, right? And the other thing, what bothers me on CI is you have this project, right? And then you have all these different jobs. Let's say quick check job, integration test job, right? And they never share the output. So the integration test job needs to recompile again, needs to regenerate the sources again, because you know what I mean? They always start from scratch. What a waste. With this build cache, it's no longer the case, right? The other thing, what we see is with some of the modern CI build infrastructures, they don't have any local state at all, right? They fire up a slave, provision the environment, run the build, kill the slave. So local state doesn't help you at all, but the distributed cache, right, or the shared cache, the remote cache, that will help you a lot. With many, many benefits. And but we have Gradle has a huge plugin ecosystem, right? And all those plugins were written before there was any awareness about the new build cache. And the key thing for the new build cache is it has to be reliable, right? You can, in the build space, when something is not 100% reliable, it's not worth the time that you save, right? So that is why the build cache is an opt-in feature. A task has to say, I'm cacheable, right? I give you an example. Let's say you write your Java compile task, just say, right? And the compile task would behave in the following way. It would pick up whatever Java version is installed on your machine to compile the code, right? So you would not define the version of the Java compiler in your input properties of the Gradle task, right? Then we would calculate the cache key based on the sources and the class path, right? And then you share the output, right? You publish the output, and then another person, right, that is on Java 8 and you were on Java 7, or even worse, the other way around, right, would say, oh, the output, this has already been built in the cache, but it was built with Java 8, and now you're in Java 7, you get Java 8 binaries, ooh, you know, then you're getting into trouble, right? And nasty mistakes happen. So that is what you need. What we do for all the Gradle build-in tasks, we make sure that all the inputs that define the tool chain that produce the output are defined. But in general, this is a great discipline. So the cache forces you to think about that. Basically, think about reproducible build and think about what actually is required. What are all the inputs, right? And then you need to make them explicit, and then they are stored in version control. You get the idea, right? So the cache forces you to think about what are actually all the inputs for that output. What is the tool chain? And then you enhance your Gradle task if necessary to capture the tool chain. But the good thing about that is, at that point, you have reproducible builds. Everything is exactly defined. The Java version, whatever makes up this output is now defined in version control. You get the idea, right? And you don't depend on what accidentally is installed on that environment. Okay, so or at the very least, right, what you can do if you say, hey, I still want to pick up whatever Java compiler is installed, you can still tell Gradle, then read the Java compiler version and make it part of the cache key that no one is picking it up that has a different version, right? Then you still have the convenience, but the cache will be reliable. And the other thing that is important, so you can say, hey, this property here, whether the logging on the console, right? So that basically the way Gradle communicates with you when you run it from the command line, this should not be part of the cache key. So you can say, hey, this just affects the console output. Don't use it for the cache key. It doesn't matter whether the compile is happening in verbose mode or not, right? The output should not be affected by that, whether the output can be reused. The interesting thing is now path sensitivity, right? If we take your sources and would use the absolute path of your sources as the cache key, well, the cache would be reliable, but no one would probably be able to reuse any output because the absolute paths are different. So that is why you can define, hey, I only want to use the path relative to my project directory, right? And you have a lot of flexibility here. Yeah, so, oops. Okay, I talked about that. So there are two locations for the new cache. I talked about it. So one is, we now call it remote cache. Our guys hate it when I talk about distributed cache. It was the old wording. I call it a remote cache. And that sits here, right? And this, usually the pattern that we recommend is the CI builds read and write to that cache, and the developer machines usually only read from that cache, right? But faster, right? But you can configure it however you want. And then we have a machine local cache. So that basically comes with Gradle and caches with output locally, as I have described, right? That is particularly interesting when you switch between branches, when you have multiple dirty branches, right? They're never published to this shared cache, right? Which is only filled by CI, so you get the idea. So Gradle build tool, in version 3.5 comes with everything you need, except it does not ship with a distributed cache backend, right? That is not, Gradle is the client of that, right? So it comes with a machine local cache, right, for caching your build output locally. It comes with everything that is necessary to calculate cache keys and communicate with the cache backend, but you need to set up your own cache backend. And there are basically three ways how you can do that. So Gradle Enterprise, as one feature, provides a highly scalable cache backend. We have an open source reference implementation. And number three is there's a clearly defined simple interface, right, that you can implement 4 REST methods and then you can provide your own cache backend that implements that interface, right? Could be an S3. There's now, for example, a simple backend for S3, right? Just as an example. Okay, so I talked about the SSD, right? We have some big big enterprise test build that is publicly available, and when you run everything from scratch, right? It takes a clean assemble. Takes 5 minutes, right? And when everything is in a distributed cache, it takes 6.4 seconds. I mean, it depends obviously on the bandwidth. When you are in an airplane, it will not be 6.4 seconds, right? But I guess most of you usually work in a high bandwidth environment, so that is pretty spectacular, right? And part of that 6.4 seconds is still Gradle configuration time. So yeah, and even if you have, let's say, builds that are a little bit faster, if it's 1 minute, if you can get it to 5 seconds, hey, you're crazy if you don't do it, right? Okay. Let's continue. The next developer productivity feature that has been released as Gradle as part of Gradle 3.4 is compile avoidance and incremental build. And I just want to quickly explain what they are about. So compile avoidance is the following capability. You have module 2 that depends on module 1. And this module 1 can be a source module that is part of your Gradle build, but it could also be an open source library. It doesn't matter. So and what compile avoidance is doing, when module 1 is changed in a way that it only affects the implementation. So there's now a terminology called when you don't change the application binary interface. It's pretty simple, right? When you, let's say, you change the application binary interface, the ABI, when you change the signature of a public method, right? Then you change the binary interface. When you change the implementation of a method, you don't change the binary interface, right? It's so, and what we do when we when Gradle uses compile avoidance, when we detect the change in module 1, so first of all, when module 1 is changed, we fully recompile it, right? And as part of the recompilation, we analyze the ABI changed of module 1. And if the ABI has not changed, then we don't recompile any modules that depend on module 1. And module 1, as I said, could also be an open source library. In this case, we wouldn't recompile it. We would just recalculate the ABI, right? And if we see it hasn't changed, right, because of the change, we would not recompile module 2. Does this make sense? And of course, it doesn't help you when all your code lives in one module. But when you have many modules, this is a spectacular accelerator of build time. Okay, so and it's a very fast check. So Gradle 3.4 comes with that feature, right? And the other thing, it improves the cacheability. So that is an interesting point I would like to talk about. Classpath hell is one of my favorite topics. Who is kind of suffering? Who is suffering from dependency management? Who considers that a pain point, kind of the dependency graph and managing that? So one thing, if you think about it, if we talked about if we cache, let's say the compile output of module 2, right, in the new build cache. Right? Part of the cache key is the class path of module 2, right? We talked about that. So, but strictly speaking, the way we have implemented that, and that is where we have a problem with compile static, but we talk about that at a later point. The way we have implemented that, we actually don't use the class path to calculate the cache key. We use the ABI signature of the class path to calculate the cache key. So that means if, let's say, you come to work in the morning, right? We will, and you have some dirty changes in module 1 that are not committed, right? So there were many changes that happened overnight, right? By the team in Bangalore, they changed tons of stuff. They changed module 2, right? In many ways, right? Module 1 was only touched by you, and it's still dirty and not committed. You get the idea, right? Then you come to work in the morning, and Gradle will check. Oh, module 2 has changed. You do an update from version control, and then usually you would need to recompile it locally. But Gradle says, hey, let's check if there is anything in the build cache that has to compile classes. And for calculating the cache key, if your changes in module 1 are non-ABI changes, we would still get the module 2 cached version for you because the cache key is still the same. Because your changes in module 1 were not affecting the ABI. Does this kind of make sense? Okay. So, and then the other thing we have shipped in Gradle 3.4 and is an incremental compile. So for the incremental compile, we do it very efficiently, but it's a more costly operation. So basically, the first check is always compile avoidance, right? But if we need to recompile, this works the following: whenever change you do to module 1, we only recompile the affected classes. We analyze, I mean, it's similar what an IDE does for you, right? We analyze the dependencies between the classes, right? And then in module 2, the same thing. We only recompile the affected classes depending on how module 2 depends on module 1. Yes, please.
So if part of the module 1 change was just like, say, pulling something out into another class that just, more of a private helper class.
Yes.
Does that impact the ABI?
No, it would not. Anything private, boom, is completely ignored.
Okay.
Yeah. So and with incremental compile, it would be let's say you would change the signature of a public method. If module 2 is not using it, we would understand that and would say, hey, it's not using it, We don't need to recompile anything in module 2. That would be then the difference between compile avoidance and incremental compile. Compile avoidance would say, oh, public signature change, module 2 needs to be recompiled. And then if incremental compile is enabled, we say, well, let's analyze this a little bit further. It's a little cost for the analysis, but that finally then tells you, hey, in this case, no, we don't need to recompile anything. So, and the effects obviously depend on the type of the project, right? Again, so this is a large project where all the code lives in one source directory. So this only benefits from incremental compile, but it's so this is Maven, 20 seconds. Gradle 3.3 was anyhow faster, 13 seconds. Now with incremental compile, 1.3 seconds, right? And this is a damn game changer. Maybe not for the CI build, although I like it when the CI builds are fast. But now let's assume you're in a fast debugging scenario, right? This makes all the difference, right? Waiting 30 seconds for every change. Oh. Yeah, it's so medium project, right? Very fast. This is now a multi-project where compile avoidance and incremental compile work together, right? And ABI breaking change. So this is where incremental compile is kicking in and making things still significantly faster. This is where compile avoidance is kicking in, right? ABI compatible change. So those numbers are pretty impressive, and you can reproduce them. So one thing I've learned when you talk about performance numbers, you need to provide test project. We say, hey, you can reproduce them yourself, right? Because it depends so much on the context. So usually we now always provide test project where you can say, hey, you can use them. Those are the projects we use to get to those numbers, right? So I'm super thrilled. And then combine that with the new build cache. This is it's a new era, seriously, if in terms of how fast you can get feedback, right? And there's one disclaimer here. Who of you is using annotation processor, something like Project Lombok or something like that? No. So at the moment, when you use annotation processors basically are compiler plugins, and they can do whatever they want. That's the problem. So for us, they can say, oh, I create 10 new classes, I delete this, whatever. So as soon as you're using annotation processors, we have to say we cannot reliably do an incremental compile, because we don't know what this annotation processor is taking as input and producing as output. So it's a big problem in the Android world, because everyone there is using annotation processors, so they kind of suffering that this is disabled when you're using annotation processors. We're working on a solution that incremental compile also works with annotation processors, but if it doesn't affect you, this is ready to go. It's very efficient, it's very fast, super excited about that. Okay, so quick time check. Okay, so this is now wondering topic-wise. Yeah, I want to talk quickly about that. So one thing that has always bothered me since I created Gradle is the following. In that respect, Gradle and Maven behaves the same way. So what we have here is a simple Gradle project, right? It has a core module, a utils module, and a sumlib module, right? So 3 modules, 3 submodules. Core depends on utils, depends on sumlib, and they also have external dependency, commons collection, commons lang, and commons IO. So when you compile core, right, with Maven or with Gradle 3.3, what will be in your compile class path, right? It's the whole transitive graph. Do you really need commons IO to compile core? No, you shouldn't, right? And so when I wrote the first version of Gradle, before 0.1, I said no, this completely sucks. So just basically tell Gradle, don't use the transitive compile class paths for compiling. So in this case, it would mean when you compile core, only put utils jar and commons collection jar in the class path for compiling, only the first level dependencies, right? And then cut it here, right? And in many cases that works, but in some cases it doesn't. And that is why I learned it doesn't work like that. For now, it was 7 years ago, I said for a short time, I switched it back to the old behavior, and it took us a while, until a couple of months ago, to finally come up with a good solution. So, okay, transitive compile class paths are evil. I mean, and I'm particularly thinking about large projects, right? So we have projects, let's say, that have 200, 300, 400 submodules, and because of the compile class paths for those projects, because of all the dependency and the transitive are massive, massive beasts. One disadvantage is already compile avoidance and incremental compile is much less effective. First of all, we have this huge beast to analyze, right, for all the classes, right, and then the bigger the class path, the more changes potentially invalidate compile avoidance, right? Makes sense. So, and at the end of the day, the class path is the surface area of your API. When you expose everything, right, it means you can use everything, right? And that's not good, right? Often 2 orders of magnitude larger than necessary, hard to debug and reason about, fragile dependency graphs, right, and terrible for incremental performance. So, and I already mentioned that. Usually that would be good enough, right? Cut this beast here, right, and often goes down here and up to the wall. So I hope I didn't blind anyone. So okay, and I don't have time to tonight to go into the details, but what Gradle Tree 4 does for you, it comes with a new Java library plugin. And with this Java library plugin, you can by default, Gradle only adds, you can now distinguish between API dependencies and implementation dependencies. So there is one scenario where you need parts of the transitive class path. Let's assume, right, utils has a class called utils servlet, right? And the utils servlet class is extending sumlib servlet, okay? And then core is extending utils servlet. Then I need sumlib in the class path to compiling core. Sumlib is now part of the API of utils, if you like, right? The compiler needs to have the extended classes, right? It cannot work otherwise. So, and now with Gradle, you have a language to tell, hey, in utils, you can now say, sumlib is an API dependency. But sumlib can say, this is just an implementation dependency. So it will not get exported, right? So that is how we have solved that. But different to compile avoidance and incremental compile, which will just work out of the box with your existing Gradle builds, to basically cut down your class paths, you have to use the new Java library plugin, and you have to use the new keyword saying this is an API dependency, this is an implementation dependency, to make use of that, right? So you have to change your builds, but it's worth it, right? And we want to take this even one step further. If you think about it, when core depends on utils, it usually doesn't depend on all of utils, but usually only depends on certain packages of utils, right? So what we will allow pretty soon is that of utils can say, not just those are my API dependency and my implementation dependencies, those are my API packages and my implementation packages. And then core cannot reach anymore into the implementation packages. The compile will fail. Say, oh, I don't know, you're trying to get a class from there. It's not in my compile class path, right? So, and obviously, when you think about Java 9, jigsaw, right? But we will enforce basically modularity with that on the build level. It works with Java 7, with Java 8, and with Java 9. And with Java 9, we will automatically create from that information the jigsaw info. So, yeah, I love it. So let's, oops, we've been there. Okay, the next thing I want to show you is a feature I also really, really like. I don't know when we introduced it, but it doesn't matter, not maybe 6 months ago. It's called Composite Builds. Can you see that in the last row? So composite builds, to demonstrate that feature, we have a very simple Gradle Java build here. It's a project called My App, right? It uses the Java, the Gradle application plugin. When you use the Gradle application plugin, it offers you functionality like you can run the application, you can create a distribution of your application with start scripts, right? And so it does more than a Java plugin. So this application has a couple of things that are interesting. Oops. Yeah, okay, I talked about that. Oops, why is that not stopping? So this application has a main class, right? And it has binary dependencies on a number utils jar and a string utils jar, which is an internal repository, let's say, in your organization, but it's a different repository, right? And if you look at the main class, what you can see is here we use the strings utils class from org sample string utils string to concatenate two strings, and we use the add method. Oops, go back. Let's go back. We use the adds method to add 15 and 10. Right? Okay, cool. So now let's call Gradle run for this Java application. And the answer is 26. Not quite right, almost. Okay, so what to do? Something is wrong with the add method. So what I did here, I now went to IntelliJ and clicked, hey, navigate me into the add method. But what is happening? Why do we have the add method? Why can we look into that? Because IntelliJ is doing a decompile, right? So what you can see is, yes, you can see here's a bug, left plus right plus 1, but of course you can't change the source code. It's decompiled binary code, right? To fix that problem, what do you have to do? You have, exactly. So and that's what we're doing. Now we're in a myutils project, right? And we say, okay, where is this damn numbers method? And here we have the numbers method, and it's easy to fix, right? Plus 1 is not quite right. And okay, now let's run the application. Everything will be good, right? 25. Who thinks it's 25? Who thinks it's 26? The others are undecided, okay. Oh, it's still 26. What happened?
You can pick up the new version of the jar file.
Yes. So I would need to either to publish to Artifactory or to publish to a local repository. So and that is a terrible debug cycle. Imagine you're doing a really serious refactoring. You always have to go in the other project, have to publish it, right? How do you work on it in the IDE as one thing? So, but that is how you had to do it with Gradle for a long time, and that's how you have to do it with Maven. What you can now do with Gradle is the following. You can say, you know what? In this case, Gradle, include another build, right? And then please replace all the binary dependencies I have, wherever it applies, with the output from that build, right? So you can basically tell Gradle, hey, look at this build, look at my binary dependencies, and wherever they are the same thing, don't use the binary dependency, build this thing from source. And you can see, right, my utils is now automatically built as if it were one build, right? And The answer is 25. The change was picked up. I didn't need to publish anything to a repository.
Did it change the Gradle file and put a new version in?
No, it's at runtime.
It's all okay.
It's all at runtime, yeah. So if you would now do it without include builds, it would be back to 26. And you can also do that. You can say, hey, create me the IDE metadata that I can work on both of the projects at the same time. And if you run that, you're now in IntelliJ, and boom, both projects are imported, and they now have source dependencies between each other. Although those are separate repositories. Make sense what is happening here? Any questions? So that means, in a way, this is now one big Gradle build. It's like as if you were working with one repository, unless you do the commits. And you can now have everything you want, right? You can do now refactoring. Hey, I want a minus method, and then you can use a quick fix, and then IntelliJ will jump into the numbers method, which is in a different repository, but it's integrated together in your IDE, right? And okay, let's. And you can say run include build. Okay, come on. And now the minus method. The answer is 5. And just to validate your point, okay, now the thing is, you don't have to specify it on the command line. You can also, in a settings.gradle, say, hey, include this build. And so in the My App project, you can say I want to persist that I want to include the build instead of the binary dependencies, and then you don't need to do it on the command line. Okay, you see it's still working. So let's remove it from here. And just to be sure, and that is an answer to your question, that is not a proof. If I run it now, it will tell me I don't know anything about a minus method, right? So what you can do, because often you say, hey, I want to aggregate 2 builds. I don't want to touch any of those projects, but I still want to aggregate them without needing to specify it on the command line. And what you can do is you can create a pure composite project, right? And this composite project is basically empty, right? Except it has a settings.gradle file where you can say, hey, I want to include 2 builds, my app and my utils, to form a composite builds. And then Gradle will figure out what dependencies do they have between each other, and wherever they have a binary dependency between each other, it will be replaced with the source dependency and built in the right order. So, and that's pretty cool. Because if you think about it, yeah, everything is working fine. If you think about it, this is a really interesting alternative to snapshots. Let's say you have CI builds for QA, where the different repos have binary dependencies against versions that are quality control and whatnot. But you would like to have one CI job, right, that integrates much earlier, right? Not with snapshots, just build everything from source and see if it's still working together. You can define such a composite project, right, and build it on CI, and that is now your integration build. And then you have the flexibility, right? Sometimes you want to have binaries depending on the stage, right? At other times you want to say, hey, build everything from source, see if it's still working, or whether we have integration problems. So
Step to go back. Since everything's at runtime, you got to have a step to go back to those projects and update the versions explicitly when you're ready to publish new versions.
Absolutely, right. So you need to have some process around that.
It's just a little bit of change in mentality.
Yes. Yes, yes, and it is, and the whole thing. I mean, continuous integration is not a trivial problem, right? When you have many teams, so it's snapshots is one way of dealing with that. Who of you has ever used snapshots, right? And and it's not without issues, right?
You gotta remember to go back and put explicit versions on those,
yes.
doing it right as well.
Yes. So and there's a latency.
At least
Yeah, there is a latency. So this is an interesting tool in your toolbox now to do integration, basically, right? And at the same time, it makes it super convenient for developers. So the use case is this quick local experimentation, right? The other is cross-repository refactoring. And a particular use case is a smooth migration from monolith to multi-repo. Let's say you have this big monolith and say, hey, I want to start making this smaller. And I want to create another repository, and I want to get one service of this monolith into this other repository, right? Many organizations have that challenge right now. Then you would say, okay, I use composite build. One composite is the monolith. The other composite is the new microservice, right? And now you can go back and forth. And imagine now together with the build cache, how fast this debug lifecycle can be, right? Compared to, oh, I always need to rebuild the monolith from scratch, takes 30 minutes, right? You see, so it's, yeah, I love that feature.
So is this a replacement? So like right now, I'm working on a couple different projects.
Yes.
What I'm having to do basically between the dependencies of them is publish to Maven local.
Yes, this you wouldn't need to do that anymore. That's exactly the replacement, right? Exactly, yes. Including that IDEA and Eclipse supported natively composite build. So I created from the command line clean IDEA. I'm old school, right? But you could tell you can tell IDEA, hey, this is a composite build, and it will do the import in the right way. It makes sense what I'm saying, right? So the import features of the IDEs for Eclipse and IntelliJ understand Gradle composite builds. And one thing that is also cool when you develop Gradle plugins, right? They live in a separate project, right? So let's say you write a new Gradle plugin for doing some source code generation, right? And then you would have a test project that is trying out the plugin. You would have the same thing. Change the Gradle plugin, publish it to a local repository, run the test build, but can define a composite between the Gradle plugin and the test project. Very, very convenient and fast Gradle plugin prototyping. So at one point, we will replace the build source concept of Gradle. We make that just a scenario of we make that just a composite build for people who are using build source. So the last thing I want to talk about is Gradle Enterprise. So what we have introduced is the concept of a build scan. Can you still see my screen? And also on the Hangout. Excellent. So let's do something here. I'm in the Gradle project itself, and just that we have something to see. Let's create a build scan for the Gradle project, whatever that build scan is. One thing you can see here is the new Gradle console that comes with Gradle 3.5. So still configuring. Let's go on. Oops. I think it's downloading something. There's some network issue here. That's weird. Something. Settings. Not sure. Must have been some network issue. So with the new console, you can now nicely see how Gradle parallelizes, right? You have for every process, you have a separate line and a command line. In any case, so I run that build with --scan. And when you run a build with --scan, what you get at the end of the build is a URL, right? So let's click this URL. And what you can see is, okay, the build that was won was Gradle clean classes, right? There's some interesting stuff here we'll talk about later. You can see the Gradle version that was used, right? And one thing you can see, hey, let's look at the output. You can say, I look at the output, say, oh, there's some red in here. What is going on? I don't have any warnings in the Gradle build. Hey, I demoed that at user groups. So I could now create here a link, and I can select this to our folks and say, hey, look at this link here. Why do we have a warning, right? And a very efficient way, right, to communicate about what happened during this build, right? Other information that is captured is very interesting, is the timeline. So what you get is, and you can of course zoom in and zoom out, right? So and it gives you a very good idea about what is happening in parallel, right, in this build. I can move along. You can see, okay, here the parallelization is good, and then we have, oh, the score compile Java, right? Is everything depends on that. So you can get a really deep insight into what is going on in your build, and potentially seeing, hey, there are optimizations, or if you have concurrency issues, you can see where our tasks run in overlap. So it's deep insights into your build. You can do other interesting things. You can say, hey, I'm interested into all the compile tasks, right? And then it shows you the compile tasks in the timeline, and then also the tasks are filtered, and you can see all the compile tasks. The longest running compile task is the Groovy compile, are the two Groovy compile tasks. So you can basically see, okay, Groovy compile is slower than Java compile, for example, right? So it's very interesting information. You can learn about the performance, right? You can do things like, okay, someone was saying, let's say someone was saying to you, hey, look at this build scan. This build was really slow. And you say, oh, I have an idea. They probably had to they had to download many dependency, and the network activity, the network connection was low. And you can see, was there any network connectivity? And you see in this case, nothing was downloaded. So that hypothesis was wrong. But you see how deep you can dive into that. And we see that all the time, especially in distributed teams. They're saying, oh, my build is slow, right? And people don't have much understanding. And you see, well, yeah, it was slow because you had to do all the downloads next time really fast, right? Just as an example, right? You can, dependency configuration will break more down, right? What exact dependencies took a long time to execute. Very interesting is task execution. So you can, talking about professionalizing the software industry, right? We can now say, okay, 148 tasks have been avoided, and 144 tasks were actually retrieved from the cache. Pretty good, right? So, but still, 197 tasks were executed, and 4 of those tasks that were executed were cacheable, and the other tasks were not cacheable. When we talked about the cache, tasks can say whether they're cacheable or not. Now I'm wondering, this is the Gradle build. 193 tasks are not cacheable. I want to dive deeper into this, right? So which task, and then you can click the link, and then you can see all the, you can query, right? Show me all the success and failed tasks that are not cacheable. And then you can get, it doesn't work on that screen. Sorry, I need to make it smaller. And then you can see, okay, the tasks that are not cacheable are the delete tasks. That's fine. The other tasks are the process resources tasks. Those are copy tasks. They shouldn't be cached either, right? And then the jar tasks shouldn't be cached either. They're just so although there are 193 tasks that are cacheable, it all makes sense that those tasks are not cacheable. But imagine you're now in a complicated build. You can now optimize cacheability, and people always changing the build. Let's say they're using an obscure Gradle plugin from the community, and now they have this task, 6 minutes, not cacheable, right? And say, damn, what is going on here, right? So let's do something about that. That we cannot accept that regression. So you finally have insights, right? And not just CI builds, but every local build, right? And Yeah, you can see how many projects. One interesting thing is it's not just for build masters, it's also for, just want to show you, oops. It's also for developers where this is very interesting. Oops. Where is my, interesting, yeah. I want this, come on, link. That's funny, using Keynote as my bookmark. So this is a link, a build scan from a build someone was running locally and a test failed. And we talked about that, I was visiting OCI, about that scenario this afternoon. So let's assume you're a developer and a local test is failing and you did everything to figure out why, you just don't understand. You need to ask for help. How do you ask for help? You have made some changes, right? You have a dirty working copy. How would you ask for help when a guy is not, or the person is not sitting right next to you? How would you discuss that? The person, let's say, is 5 kilometers down the road. What would you do to ask for help? You would write an email?
I am.
And what would you say? My test not working. And you guys, well, can you give me some more information? So what would be one thing you would maybe the test output report, right? And then the guy's saying, okay, test output. What were your changes? I don't know. What were your dependency? Oh yeah, I mean your dependency report. Okay, you see, highly inefficient, right? So here you can say, hey, this test is failing, and not just, you can have a deep link, right? Let's say, you can say, hey, look, this test is failing. I am in the URL, right? And then the guy looks at this and says, okay, interesting. I had a similar problem. The person might say, and it was in my case related to the version of Guava. So let's quickly go to the dependencies, right? And let me see what version you're using for Guava. And then you see, oh, it's 2.7.5. Yeah, it was the same thing for me. And then this guy IAMs back and says, hey, look at the dependency search. Look at the version of Guava. It's 2.7.5. I think that's the problem. Change it and let's see what is going to happen, right? And this is when we talk about accelerate debugging, right? Making collaboration easier. And this is the last thing. Now, three more things I want to show you. And what I think is particularly cool is that, let's go back here, so here we have a very simple, hold on, sorry. A very simple Gradle build. And so this is how you use the build scan plugin. You just say, hey, build scan, if you want to use, we offer a community version to just simply create build scans. I agree to the license agreement, and then it automatically publishes them to our hosted service. If you use Gradle Enterprise, you specify the URL of the Gradle Enterprise instance. That's all you need to do. And from that point onwards, your data is sent, right? And you can use build scans. This is a very simple Java build, a single project that is using check style and just a Java library. But what the build scan plugin provides you an API to capture more data. And that is what I want to show you now. So what we're doing is we say, hey, Gradle, if this build is happening in a CI environment, create a tag for the build scan that is called CI. And create a custom link that is called CI build that links from the build scan back, let's say, to the Jenkins job page for that build, right? And if it's a local build, we tag it with local, right? And those tags are not nice. You can also search for them and filter by them. And then the next thing we do, and that is something at one point that will be fully baked into build scans, but for now, it just shows you how powerful the API is that we provide. You can say, okay, let's determine the commit ID, right? And then add a custom value. Git commit ID is the following commit ID, and create a link that is called source that links to the GitHub Enterprise or to the GitHub URL of that specific commit, right? Okay, the next thing we're doing is branch name, right? Get the branch name and add it as a custom value. And then the typical use case, it's not working, I didn't change anything though, right? Well, so let's capture the status, right? And when something has changed, right, tag the build as dirty, right? Plus publish all the files that are dirty, right? And then the next thing I really that is now the pinnacle, right? We're saying, hey, so this is a local build, right? Nothing has been pushed to your GitHub server, right? It's only in your local GitHub, the dirtiness, right? So what we are now doing is we're now creating a Git diff with your changes compared to the last commit, and then we publish the diff as a gist and create a link with a URL to the gist that is your diff. That makes sense. You will see it in a second. And then one other capability that is really interesting. In this case, we use check style. So check style has all these XML reports, right, that are hidden locally. So what we are doing, we pass those XML reports and create custom values for every check style error that we find. And that is something you can do with whatever custom reports you have, right? And then finally, with a failure, we say, and if the failure is instance of a certain exception type, then we create a link with that opens up an issue in the issue tracker to make it super easy for people. If there's certain weird behavior with the build, just click this link, right, with the URL of the build scan, boom, and file an issue. Does it make sense? Right. So you see, it's a very powerful concept. So now let's see that in action. No, let's just do build. And this build fails by design because of a check style error. And here we have the URL of the build scan. And you can see this is a local build, it was dirty. So if the person said, oh, I haven't changed anything, you know, well, I'm not quite sure about that. So here you have, and so you can see, oh, it's dirty, right? And let's look at the diff. And now here you have the diff. In this case, it's only the build file that has changed. In normal case, it would be code that has changed, right? And here's the link to the GitHub commit URL. Here you can create a foreign copy because the build failed, right? And we can look at custom values. And you can see, hey, show me all the check style issues, and then you can see, this is why check style failed, or you can say, by the way, what are the Git values, and you can see this is the branch name, this is the commit ID, and those are the files that have been touched, right? So now you can add a lot of context via that. So, and again, the purpose is make collaboration easy, give people context to reason about a problem, right? That is one thing, and the other thing is collect data that helps you to make developer more productive. So, right, and are captured, right? And we have many organizations that are now creating 10,000 build scans per day, right? And they learn a lot of interesting stuff they have never thought about that is happening, right? And you can now, for example, say, by the way, is anyone building something dirty? So if that were empty in your organization, what would it tell you? Or people just commit. People, yeah, they never build. They just share their shit, right, without caring about the quality and saying, oh, see, I will tell me, right? If someone else is broken by that, well, they can have a cup of coffee. So it tells you something. Either it tells you the first, or that their quality awareness could be improved. It's educational opportunity. and then you could ask questions. And I would say, if you go to an organization, right, and just think about your organization, what is the ratio between CI builds and local builds? Could you give an answer? No one can, right? It's fascinating, right? And so, and then because let's say if there are no local builds, would be the same thing with the dirty stuff, right? And if there are local builds, say, oh, so many local builds, we better make them fast because people are waiting all the time for them to get finished, right? You get the idea. So we could now say, hey, how many local builds do we have, right? And yeah, I mean, yeah, so quite a few, right? So so you see, you can, so we capture all your builds and you can filter for various things. But there's also, and I will now show you the next thing, an export API that you can use. I will show you two more things and then I'm done. So one is export and stream your build data. So what you can see here, they're now in all of those windows, they're Gradle builds that are running. And what we have here, and that is available on GitHub, this is a client, a JavaScript client that uses the export API, right? And basically it hooks into the stream of the Gradle Enterprise export API and does some visualization. It basically is the client is interested in, is the build successful or failing, and how long does it take, right? And then you see the first build was running, the next build, 5.4 seconds was also successful. Then the third build is running, and it failed in 4.69 seconds, right? And so on and so on and so on. And there you have the ratio. So you could, yeah, you get the idea. And so basically all the data, including the custom data that you collect, is accessible via the export API. So you could also measure how many are local builds, how many are CI builds, whatever, how many check style errors, right? It doesn't matter, and faster and faster, right? So that is a nice dashboard, real time. Or you can add, people. Let's say people are complaining that there are out of memory exceptions kind of happening too often, right? And you can say that they really bother me. They're not reproducible, right? But they happen very often. So let's create a quick kind of dashboard for, hey, what builds have out of memory exceptions, right? And then you could program, say, hey, send me a text message, right? You get the idea, right? So it's very powerful to have deep insights. And then the other thing I want to show you in terms of developer debugging acceleration is comparison of builds. So it worked locally, it failed on CI. Why? Right? Maybe it picked up a Maven snapshot dependency on CI that was of a different version. How would you learn about that? Whether the CI build picked up a different version of the snapshot dependency than your local build. You don't have an answer? Well, me neither. Just no way. Right, terrible. You're completely stuck. You think it's unlikely, but maybe it was the reason. So your debugging becomes so inefficient because you have those hypotheses and you cannot invalidate them, or only with, I don't know, right? So what you can do with Gradle, I mean, the dependencies are captured, so you could do it manually. But here we run a build, and then we tell Gradle, hey, build again and refresh the dependencies so that if there's a newer version, we would pick it up. We use dynamic versions in that case, right? So we create a second build. And what you can do now is with build A and build B, you can now go to Gradle Enterprise and you can say, hey, this is build A and this is build B. One is succeeding, one is failing. Please compare. And then we compare the dependencies. And then we see, oh, they're not different, right? They are different, right? And let's look. It's the test runtime dependency that is different, and A was using 1.0 and B was using 1.1, right? And even if that were, and that's very important information. But for me, when I'm debugging, even just a quick check, when I think this is an unlikely thing, I don't expect it, but if I get some fast confirmation, yeah, dependencies are the same, they haven't changed. Okay, then you can continue with a peace of mind that's really worthwhile your time to debug in the area that you think is most likely. But basically, being able to quickly exclude certain reasons for a problem is like extremely valuable, right? So
If you're using snapshots on that, would it So it wouldn't have different versions, would it just tell you there's a binary difference between these two jars?
It would show you the snapshot version, right? And then it would provide you, so in Gradle, we distinguish between a requested dependency and a selected dependency. The requested dependency would be, let's say, 1 snapshot. The selected dependency would be 1 dash the timestamp, right? And we would tell you both. We would say, hey, you could link back to the build scan where we would show you this was requested and this was selected. So you would get the exact version of that. Yes. So that's it. Thank you very much. Happy to take any questions that you have.
How much is it?
uh,
I'm half serious.
yeah, no, I hope.
Yeah, I can address that. Yeah, so we charge annual subscription basis per seat. It's $350 per year per seat for developers for Gradle Enterprise. That includes text support.
So it doesn't matter how many CI machines we're using, it's just like developer seats.
Yep.
What's the elephant?
What's the elephant? The elephant is the pun.
I assume there's a story there.
There's a story there. So the elephant is build infrastructure. It's not this kind of elf-like thing. It's a tough business, right? It's sweaty. It's hard work. So the elephant kind of represents that this is hard forest work, right? But it's not something light-footed or whatnot. Builds are complex beasts, right? And they have a tendency to do requests. You have a lot of pressure, right? Every change affects every developer, right? So it's kind of, and Gradle is basically the Gradle friend is your friend in that world. Strong, intelligent, doesn't forget now with the new build cache. So, okay, great, thank you.
Thank you.